Let's add some curves to this egg. We can use a shorthand border radius notation to create a uniform radius on our element. This applies a 50% radius to the top left, top right, bottom right, and the bottom left of our element. That means we have a radius that is both 50% of the element's width and 50% of the element's height. This shape isn't quite right. We can use a longhand notation that allows us to define a border radius for top left, top right, bottom right, and bottom left. We can see with our shape that the top left of our element has a border radius of 35%. That's 35% going from the top left to the top right horizontally, and 35% going from the top left to the bottom left vertically. For our shape, we might decide that we only need a border radius for the top left and the top right corners. But that's still not right. You can see the curve here. That curve should really be going more angled across here. Instead it does this straight up and then around. The real magic is when we use an optional / in our border radius. This allows us to define both a horizontal and a vertical radius for each corner. That gives us the shape we want. We apply our border radius to the top two corners of our element. 50% horizontally and 100% vertically. That means we have a radius that spans from the top center of our element to each corner, each bottom corner of our element. One tip for finding the correct border radius is to use your browser's developer tools. For example, in Chrome, you can inspect a border radius and use your mouse wheel to adjust the values. As we can see here, a horizontal value of 0% for our top left corner and a vertical value of 100% for our top left corner gives us an almost square corner. But bumping that value back up to 50% gives us the shape that we wanted. So in review, the shorthand border radius notation allows us to create more basic shapes, where 50% would give us a circle. Using a longhand notation, we're able to define a radius for each corner of our element, going from top left to top right, to bottom right, to bottom left. But if we want full control, we can use the optional / to define both a horizontal and a vertical radius for each corner of our element. This allows us to create more complex shapes with our CSS. Start by opening Chrome's developer tools. Go to Settings, then Experiments, then enable CSS Overview. After restarting Chrome's developer tools, you will see a CSS Overview tab. Click Capture Overview to start. The Overview tab gives you a summary of your page's CSS, along with details about colors, fonts, unused declarations, and media queries. We can see here, these are the colors I have used on j.dev. The colors are separated into different categories, such as text color, and here we can see the fill colors that are used on icons and the avatar on my page. One interesting feature of the CSS Overview panel is being able to see unused declarations for your CSS. These are declarations in your styles which have no effect. To show this feature in action, I've added an unused declaration to the local development version of my page. Here, vertical align will have no effect and is essentially unused. Running the CSS Overview tool shows me that unused declaration. Vertical alignment applied to element which is neither inline nor table cell. Clicking the occurrences shows me the affected elements. So in review, the new CSS Overview feature of Chrome's developer tools is a nifty way to get an overview of your page's CSS, whether it be a quick summary, an overview of your page's colors, the font info for your page, checking if there are any unused declarations, or getting an idea of the media queries that are in play. Let's start by removing the text decoration from our links. The idea is to recreate that text decoration with background image. We can use a linear gradient that we rotate by 90 degrees and keep the color constant throughout. Our linear gradient is covering the entire link background, so we can use background size to make our background look like an underline. There's a reason we see no change. By default, our background will repeat, so we need to set background repeat to no repeat. But now, even though our underline is the right width, it's in the wrong position. This line needs to be under each word. To fix that, we can use background position with an X of 0 and a Y of 100%. Now our link underlines are in the correct place. We can take some of these values and turn them into CSS variables. This will make it easier to maintain our effect. To start, we have the underline color, and the underline width. To create the little animated block, we can use a second background image. This is also rotated 90 degrees, and let's use the background color. This will give an effect of part of our link underline being cut out. Because our new linear gradient appears before our underline gradient, it hides the underline gradient. This is also because its background size is the same as the underline. To solve this, we can use a second background size declaration. We can use the underline width from before for the height, but we are using 50 pixels for the width. We can see now our link underline is missing the first 50 pixels because our new linear gradient overlaps our underline. Adding a second background position declaration will move that block. Now we can see our block has moved 50 pixels. We want this to be maintainable, so let's make a variable for our block width. And let's update our background declarations to use that new block width variable. Now we can update the variable to update the size. By default, we want this block to be hidden out of the way, so we can use CSS calc to multiply the block width by -1. That hides our block because now the background position is minus the block size, which would put it out of view. On hover, we want to update the position of that block so that it travels along our link. We update its horizontal position to be 100% plus the underline block width. Its vertical position remains the same, as does the position of the underline. As our vertical background position never changes, we can refactor to use background position Y and background position X. Then in our hover, we only need to change background position X. Hovering the link at this time will have no effect, as there's no CSS transition. So to see the animated effect, we need a CSS transition, and we are going to transition background position X for 0.5 seconds. Now when we hover our link, we can see the little block travel along the link. A nice touch might be to have a reduced alpha on our link underlines, and use an increased alpha on hover. This would require updating our background image to use the hover color for the underline on hover. We can check this by hovering over our link. So in review, we can create this animated underline effect by using multiple background images on our links. We use one image as the underline and one image for a block, and on hover we update the background position and use a CSS transition to give it that smooth animated look. By using CSS variables, we're able to create a maintainable solution. We have a basic button with some basic styling. Let's add some color to our button. Let's go with hash E74C3C. While we're there, let's change the text color. Now we have a button with this red color. But what if we want a color change on hover or active states? We could use a color picker to find different variants of our color for the different states. But an alternative approach might be to change the color space we use to HSL. Now on hover, we can darken our color by adjusting the lightness of our HSL. Now when we hover, we should see a change. We can update the active color to be even darker. And now we have 3 background color states based off of changing the lightness. And we didn't need to use a color picker to go and find the extra colors. Let's update our transition so that the background color also transitions. And now we have a button whose background color changes for the different states. We adjust the lightness to our needs. An added benefit of using the HSL color space is that we can take that lightness and turn it into a CSS variable. And then we can use scoped variables for the different button states. We can see here our button still behaves the same, but taking that combination of the HSL color space and CSS variables, we can take it a little further. Now we can change the hue variable and get a similar result without having to go and find those colors. And then we might decide to take this further by creating variants of our button. Maybe we have a confirm button, a delete button, and a warning button. We can update our button styles to use the new button class and set our default hue to 190. And then for each variant, set a scoped hue. Maybe confirm is 90, warning is 45, and delete is 10. Now we have 4 button variants that all work in a similar way using the HSL color space and scoped CSS variables. So in review, we can leverage the HSL color space in combination with scoped CSS variables to quickly prototype different variants of our UI. In this case, buttons. Start by profiling the render performance for the page. And looking at the summary panel, we can see that 583 milliseconds were used for rendering our page. If we inspect the markup for our page, we may be able to spot opportunities where we can use content visibility auto. On our page, we can see that the content is split over many section elements. So let's try section, content, visibility, auto. Then we can reprofile our page. And wow, notice how our rendering time has dropped from 583 milliseconds to 6 milliseconds. And that's because content visibility auto applied to our section elements tells the browser to only worry about rendering the section elements who appear above the fold on initial load. However, if we scroll the content, you can see that the scroll bar is jumping. This is because all of our sections assume a height of 0 until they are rendered. To combat this, we can use contain intrinsic size. And for our example, let's set this to 1000 pixels. Reload our page, and now as we scroll, we see less of a scroll bar jump. This is because contain intrinsic size tells the browser what the placeholder or natural size of our section elements will be. And that means our scroll bar will jump around less. And that is because the browser will think that our section elements are around 1000 pixels and then recalculate their size dependent on their content from 1000 pixels instead of 0 pixels. So in review, the content visibility property has the potential to significantly reduce page load times and improve performance. Use content visibility with the value auto to skip the rendering of an element when it is off screen or below the fold. To combat scroll jumping, use the property contain intrinsic size with a value that you feel is appropriate and matches up roughly to the element size that you're skipping the rendering of. Start by creating an element for our loading animation. Then we need to create some styles for our loader. Let's start by adding a solid 10 pixels white border. Let's make our loading animation round with border radius 50%, and let's increase the height and width to 10 vmin. Spinning this element currently will give no visual indication that anything is happening. Let's change the border left color to HSL 280 50 40. And let's do the same for the right color. To make our element spin, we need to define a set of keyframes. Here we name our keyframes spin. We can use the keywords from and to. These are equal to 0% and 100%. At the start of our keyframes, we want our element to be rotated by 0 degrees, and to do that, we can use a transform. By the end of our keyframes, we want that element to have span 360 degrees. Now we need to apply that animation to our element. Define an animation name, spin, and apply an animation duration. Here we are going to use 1 second, but any second or millisecond duration will work. Refresh our page, and our element span once, but we want our element to spin infinitely, so we can use animation iteration count with the keyword infinite. And now our element infinitely spins round. However, the speed isn't quite right. To change that, we can update the animation timing function for our element, and we want our element to continuously spin at the same speed, so we use the linear value. We can use the animation property as a shorthand to tidy this up. The value will be spin, which is the name, duration 1 second, the iteration count infinite, and the timing function linear. If we remove those previous declarations and save, we can see that our element is still spinning as intended. We can also tidy up our keyframes. As the initial state of our element matches the initial state of the keyframe, we can remove the declaration for 0%, and that gives us a basic loading animation using CSS. So in review, we can use CSS animation to take a styled static element and create a loading animation. We've defined a set of keyframes that spins our element 360 degrees that we animate infinitely and linearly 1 second at a time. For this example, we've opted to use the animation shorthand property, and we've refactored our keyframes by removing the 0% declaration that matched the initial state of our element. We want to apply a drop shadow to this image, a shadow that follows the outline of our image. This image is a transparent PNG. We may initially reach for the box shadow property, but this won't work because it applies a shadow to the box model of our image. To achieve that drop shadow effect, we can use the CSS filter property with the drop shadow function. We're going to match this closely to our box shadow, so we have an offset X of 10 pixels, an offset Y of 10 pixels, a blur radius of 10 pixels, and we use the same color as we did for the box shadow. Now we have a drop shadow that follows the outline of our image. It's worth noting that the blur radius and the color are both optional, but this results in a much harsher drop shadow with no blurring and black as the default color. We can apply a drop shadow to any element. Here we've updated our image to be enclosed within a figure tag, and it also has a caption. Instead of applying the drop shadow to the image, we now apply it to the containing element, which is the figure element. We can see how that drop shadow follows the outline of the figure element's children, the image and the fig caption. So in review, we can use the CSS filter property with the drop shadow function to create a drop shadow around an element's content. This is particularly useful where the outline of an element's content is not basic, where we might have previously opted to use a box shadow. We have an image, and we're going to use CSS pseudo elements to create our effect. CSS pseudo elements can't be used with the image tag, so we create this wrapper element. We've given it the class duotone. The idea is to cover that wrapper element with two absolutely positioned pseudo elements. So we apply position relative to our wrapper. Next, we need to populate those two pseudo elements. To do this, we use content, and we can leave it as an empty string. To cover the parent element, we use position absolute with a height of 100% and a width of 100%, and we set top 0 and left 0. We won't see anything until we apply some color. So let's apply a background color. We will go with HSL 0, 80%, 50%, which gives us a red color. For our before pseudo element, let's go with a blue color. HSL 220, 80, 50. At the moment, our image is completely blocked by the two pseudo elements. We see a red square because the after pseudo element sits higher than the before pseudo element. For the duotone effect, we can use mixed blend mode. And for the after pseudo element, we're going to use the lighten value. See how our square has changed color to this almost lilac/pink color? That is because the mixed blend mode property defines how an element's content should blend with its background, in this case the parent's background, and currently the blue of the before pseudo element. So we get this blend where we have like a pink color. For our before pseudo element, we're going to use mixed blend mode with the value darken. And now we have the duotone effect on our image. There are various values for mixed blend mode. In this example, we've decided to use lighten and darken. This means that the background is replaced where the content is either lighter or darker, depending on the value lighten or darken. It's worth experimenting with different color combinations to see what kind of effects you can achieve. And experimenting with different mixed blend mode values will also yield different results. So in review, we can use CSS mixed blend mode to create a duotone effect for an image by using two CSS pseudo elements of a containing element around our image. We've used the mixed blend mode values lighten and darken, and we've experimented with different color combinations. We want to maintain a consistent aspect ratio with these images. Currently they have no explicit sizing and use their intrinsic sizes. Let's start by defining a desired height for the images, and let's go with 200 pixels. We apply that through the height property, and we can see now our images are all 200 pixels tall. Next, let's define an aspect ratio variable, and let's start with the common 16:9, and we can represent this with calc 16/9. To calculate the width, we can use calc var height multiplied by var aspect ratio. The last thing to do is apply the width. And now all of our images have a 16:9 aspect ratio. We can update that aspect ratio variable to play with different aspect ratios, for example 4:3 or even 1:1. Or maybe we experiment with different desired heights. We could even use a responsive unit like vmin. That means our elements will responsively scale with the viewport but maintain their defined aspect ratio. So in review, we can use CSS variables to maintain an aspect ratio for our elements by using the calc function to represent an aspect ratio, defining a desired height for our element, and then using calc again to multiply that by our aspect ratio. Let's create a face for our head. Let's start with the left eyebrow. Let's position it at 0, 0 and give it a width of 6 vmin and a height of 2 vmin. And let's make sure that it doesn't repeat. And here's that eyebrow that we've created. To create a quadrilateral with linear gradient, we use a linear gradient from one color to that same color, and then we can change its position and sizing with background position and background size. Let's move that left eyebrow so it's 25% across and 15% down. Let's create the right eyebrow by duplicating the left one, and we can update background position X to 75%. And there's our right eyebrow. Next, we need to create the eyes, and for this we can use radial gradient to create circles. We can use the color stop at 50%. That circle's clearly too big, so we need to position it and size it accordingly. Let's go with 25% for background position X, 35% background position Y. Let's give it a size of 5 vmin, and once again, let's make sure it doesn't repeat. That looks good for the left eye. So let's duplicate that and update background position X to give us the right eye. How about the eye twinkle? Well, for that we can duplicate one of the eyes, and let's switch from transparent to red to see what we're working with. So we can see this is our background image. This circle needs to be smaller and positioned differently. Let's try a circle at 40%, 40%. Let's change it to white and alter the color stop to 10%. It doesn't look like it has changed, but that's because this background image is now beneath this eye image. So we need to move it up, and now we can see the twinkle. Change red back to transparent, and now there's a twinkle in the eye. To create the left eye twinkle, duplicate and place above the left eye. We also need to update background position X to 25%, and there's the left twinkle. The last piece to create is the mouth, and we are going to create a smile, so we will use a radial gradient with the color stop. Let's position it at 50%, 50%, and size it as 10 vmin with no repeat. This isn't the shape we want, and it's also not in the right position. Let's start by changing transparent to red so we can see the bounds of our background image. And what we're looking to do is create this circle and cut it off the bounds of the background image to create a half circle. Let's update background position Y, and we can imagine now that the mouth will be in the right position if we can get the circle right. To get the circle in the right position, we need to update the circle's position for our radial gradient, and we'll go with 50% on the x-axis and 0% on the y. That's almost there, but now the radius of the circle is too large, so we can update the color stop, accommodate. Let's try 44, and that looks just about right. Remove the red, back to transparent, and there's our face built with layered background images using a single element. We can tidy this up a little bit and make it easier to work with. Let's start by removing these duplicate no repeat declarations. We can replace them by declaring background repeat, no repeat after our background declaration. If you're going to create CSS art using single elements and layered background images, use CSS variables for each background image declaration. This can make maintenance much easier down the line. Now when you look at your background declaration, it's easier to distinguish which parts are where. This will also make it easier when you need to change the order of things. So in review, we can take advantage of how the background property allows us to layer multiple background images, comma separated, to create single element CSS art. We can use a linear gradient from one color to that same color to create quadrilaterals that we then position and size using the background shorthand notation, where the structure is background image, background position X, background position Y, background size X, and background size Y. We can create circles using radial gradients, and we can use the color stop in our gradients and the circle positioning to change the position and size of those circles. A good example being the mouth, where we clip the circle by positioning the circle in our radial gradient at 0% on the y-axis, which clips it out of the background image. So we don't repeat ourselves, we can declare background repeat, no repeat after our background declaration. And to make things easier to maintain, we can split our background images into CSS variables. This makes it easier to change the order of the background images. And as we saw, the order of background images works differently to the Z index, whereby images that appear first appear higher than those that come later. Let's transform this image using this transformed class. Start by using the transformed selector, and then using transform, rotate, and let's say 90 degrees. Alternatively, we could apply that directly to the image selector and use the transformed class to set a CSS variable of rotation. If we update our transform to use var rotation and fall back to 0 degrees, we see no change. If we update that rotation value, we can see the changes reflected on our image. Let's say for our image that we want to rotate it and then scale it down and then translate it on the x-axis -100%. When an image is transformed, we might want to apply only the rotation and the translation. We might question why not create that transform under the transformed class. However, now the transform rule is in 2 places, and that could make maintenance harder. Let's remove that rule and let's add a translation variable of -100%, and then let's update our translate, and we see no change. If we update this to 200, the image moves up. We might introduce a second image that isn't transformed. This image is just being scaled down to 0.5, but it doesn't rotate or translate. We could introduce a scale variable for both of our images and update our transform to make use of that scale. We can see the second image is now scaled to 0.75. Maybe after we've rotated, scaled, and translated our image, we would then like to skew it by 20 degrees. But we only want to apply it to the transformed one, so we create another variable. We can add skew to our transformed class, and now the top one is skewed by 20 degrees. There is an issue creeping in here though. For each transform, we're adding a new variable, and we need to remember the names of these variables. And as our CSS grows, that could become more complicated. What we can do is use CSS variables almost like a boolean. We've created a transformed variable that we're going to use with calc to calculate the transform to be applied. We can do var transformed times 90 degrees for the rotation. We can do the same for the translation. Calc var transformed times minus 100%. And lastly, the skew. Calc var transformed times 20 degrees. We can then remove our variables from the transformed class, and as you can see, nothing has changed. However, if we change transform to 0, our image returns to the scaled down state of 0.5 defined here. Now we're able to use transformed almost like a boolean. We can actually remove the transformed class and apply transformed through the env of type selector to apply it to the first image or even the second image. And that's it. That's how you use CSS variables almost as a boolean value. So in review, by using CSS variables almost as a boolean value in combination with calc, we're able to potentially ease the maintenance of some of our styles by not duplicating certain rules and by abstracting other areas of our CSS away from areas where we might be doing things like transform logic. For our example, transformed is set to 1, but that rule is abstracted away from having to worry about how much we are rotating an element, how much we're translating it, how much we're skewing it, and in what order. Start by creating an element for our cuboid. Let's give it the class name cuboid. Our cuboid needs 6 sides, so let's create 6 child elements with the class cuboid side. To differentiate the sides, I'm going to give each a number, and here are the cuboid sides within the cuboid. Let's start by defining some styles for the cuboid element. We can use CSS variables to define a width, a height, and the depth of our cuboid. An equal width, height, and depth will give us a cube. Let's apply a background color, and let's use HSLA 0, 0%, 100%, 0.2. Each side will need to be absolutely positioned, so let's use position relative on the cuboid. Let's begin styling the sides. Let's give them the same background color, HSLA 0, 0%, 0.2. Let's also give them absolute positioning. We can use the env of type selector to style each side. Let's start with the first side. The height will be the height we defined for the cuboid, and the width will be the width. Then we are ready to transform that side, and we want to translate it half of the depth on the z-axis. For this, we can use calc var depth times 0.5. Wait, we didn't see any change. To see our changes, let's rotate the cuboid. Let's rotate it on the x-axis by 24 degrees and on the y-axis by 32 degrees. The first cuboid side should have moved on the z-axis, but nothing has changed, and that is because we need to apply transform style, preserve 3D to the cuboid. Now we can see that our cuboid side actually went further back on the z-axis. So if we times the depth by a negative, it will come forwards. The second side we want to appear at the back, and the rule is almost the same. So we can copy our env of type selector and change it to the second side, and we can create a coefficient CSS variable that we use to calculate the distance on the z-axis. If we swap that out, we should see no change, but if we change that scoped variable for the second side to 0.5, the second side appears where we expect. If we change the depth of our cuboid to 200 pixels, those sides move further out. Let's use the third and fourth sides as the left and right side of our cuboid. We can start with the same rule, but this time it's env of type 3. And for the left and right sides, the height is var height, but the width is var depth. To transform the left side, we want to rotate on the y-axis by 90 degrees and then translate on the z-axis by minus half of the width. To do this, we use calc var width times minus 0.5, and we can see our third side, the left side. The right side will be the same, however it will rotate minus 90 degrees. So we can create another scoped variable of rotation and put that into our transform. Then we can create a rule for the fourth side that updates the rotation to minus 90 degrees. And now we can see the fourth side is here. However, if we update the width, sides 3 and 4 are now not in the correct place. And that's because they implicitly used a left 0 and top 0 for their absolute positioning. To fix that, let's apply left 50% and top 50%. And before our other transforms, let's translate by minus 50% and minus 50% to center them. And now our sides are in the correct place. We can now update our width and the sides follow. For sides 5 and 6, these are the top and bottom of the cuboid, and we can do a similar thing again. The height will be the depth, and the width will be the width. We will need to apply left 50% and top 50% again, and then we need to transform that side. Let's start by translating it by minus 50% and minus 50% to center it, and then rotating it on the x-axis by minus 90 degrees, and then translating it on the z-axis by half of the height. We can use calc var height times minus 0.5. And now the fifth side is on the top. We can use the same technique as previous and create a variable for the rotation. Let's use a default of minus 90 degrees and substitute that into our transform. Then for the sixth side, we update rotation to be 90 degrees. And there we have it, a cuboid. Let's remove the background color from the root element. Let's also remove the numbers from each side. And now we can configure different widths, heights, and depths. So a depth of 200 pixels, a height of 300 pixels, and a width of 400 pixels. We could even use a responsive unit like vmin to create a cuboid that will scale with the viewport. Depending on the requirement, we might also change the perspective of our scene. We could even add a second cuboid, and due to the way scope CSS variables work, we could give it a different width, a different height, and a different depth without having to repeat all those styles again. So in review, we can use CSS transforms with the preserve 3D transform style to create 3D cuboids with CSS. If we combine our solution with scoped CSS variables and use calc, we're able to create configurable cuboids where we can define a width, height, and depth to configure the size of our cuboids. We have 4 colors, a color for the background and a color for color, and then a dark variant of each. When we tap our page, the colors alternate between the variants. This is made possible with a dark class name that changes the background and color to the dark variant. If we tap the page, we can see the class being toggled. We can remove the rule using the dark class name, and then we can introduce a dark variable with a default value of 0. If we look at our BG variable and BG dark variable, the difference is in the lightness, which is 80% and 20%. We could refactor this to be one variable using HSL and calc with our new dark variable. We can use calc 80 minus var dark times 60 times 1%. We can use dark as a binary value, either 1 or 0. The difference between 80% and 20% is 60, so times dark by 60 and subtract that from 80 to get the correct lightness. Remove our deprecated background variables, and if we set dark to 1, our page now uses the darker background variant. If we set it back to 0, it uses the light variant. Let's do the same for the color variable. Here we have HSL 190, 20%, and in this case calc 30 plus var dark times 30 times 1%. Remove the deprecated color variables, and if we change dark to 1, we get the light color and the dark background, and if we change dark to 0, we get the light background and the dark color. The page has been updated to toggle that dark variable on tap, and we can see the dark variable on the HTML tag change as the page is tapped between 1 and 0. So in review, we can use CSS variables using the HSL color space and calc to implement dark mode, where we use a CSS variable as a binary value that can be used for arithmetic to calculate the lightness in our colors. This could also be extended to the hue and the saturation, and isn't limited to dark mode. It could also be used for theme switching. Here we have a page with some anchor tags that are pointing at headings on our page, which relate to these sections. By clicking an anchor tag, the browser will take us to that section. If we want to apply a transition to that navigation, we can use HTML scroll behavior smooth. And now when we click one of our anchor tags, the browser will transition that navigation. That's great, but what if you wanted to navigate through some inline search results? You'll get the transition each time, and that could get annoying for your users. To combat this, we can use the pseudo selector focus within, and now the browser won't transition between our search results. However, now we've lost the transition when using the anchor tags too. To fix that, we can use tab index -1 on each of our headings. And now we have the navigation transitions back for our anchor tags. It's down to you how you want to style the outlining though. It's worth noting that these transitions aren't going to be suitable for everyone. So we can use the media query prefers reduced motion to use scroll behavior auto. And that's how we can use CSS to create animated anchor scrolling that respects users who prefer reduced motion and doesn't annoy users when they're trying to navigate through inline search results. So in review, use scroll behavior smooth for animated anchor scrolling, but use the focus within pseudo selector so that it isn't activated when users navigate inline search results. If we are going to use the focus within pseudo selector, we also need to apply a tab index attribute with a value of -1 to the elements we are going to navigate to. To turn off the rule for those that prefer reduced motion, wrap the rule in a prefers reduced motion media query and set the scroll behavior to auto. We've got some markup with some anchor tags and some headings, and we can use the anchor tags to navigate to the headings. What you'll notice though is that our heading has no breathing room above it. To combat this, we can use scroll, margin top, and then provide a value. Now when we use our anchor tag, our content has that little bit of breathing room defined by scroll margin top. What if we have different heading types such as H3 and H4? We could define a list of all the elements that need scroll margin top, but what would be neater is to just use scroll margin top on any element that has an ID attribute. One popular layout style is to have a fixed position nav. So let's set position fixed and give it a border bottom of 1 pixel solid white. Now if we use our anchor tag to scroll to section 2, we'll see that section 2 is cut off by our new fixed position nav. To combat this, we can use CSS variables. Let's create a variable for the header height and let's set it to 80 pixels. We can set the height of our nav using that new variable and then account for it in our scroll margin top by using calc. Calc var header height plus 2rem. If we try navigating with our anchor tag again, we scroll to the section with the breathing room of the header plus the scroll margin top that we defined previously. So in review, we can use CSS scroll margin top to give our elements a little bit of breathing room when we use anchor scrolling. Instead of listing out all the elements that we need to apply scroll margin top to, a neat little trick is to use a selector for an ID attribute. If we have a layout with a fixed position nav, we can use CSS variables to combat this by defining a header height that we can then use in calc and still give our elements that little bit of breathing room. Here we have an element with a linear gradient background image that uses a CSS variable as a color stop. Wave is set to 50%, and when we hover the element, wave changes to 75%. We want to transition the color stop so it moves smoothly between the two states. Using transition background doesn't work, but we can use CSS app property to give more contextual information to the browser, which will allow us to transition and animate CSS variables. Define a property using app property and then a variable name prefixed by 2 hyphens. Let's give our property an initial value of 50%, an inherits of false, which tells the browser whether this value is inherited from the parent or not. Lastly, we define a syntax, which in this case is going to be percentage. We are using a value of percentage because our custom property wave is a percentage value. There are other values you can use for syntax such as image, URL, angle, and setting a syntax allows the browser to type check our custom properties. We can now remove wave's declaration here because we have it set in the initial value. And if we set the transition to wave 0.2 seconds, we can now transition our linear gradient on hover. Perhaps we'd like to add a second wave to our background image. We can see here it's using a color stop of 60%. But what if we wanted to also transition this? Let's create a second property called var wave 2. We'll transition this property the same as we do var wave, and on hover wave 2 will go to 75% and wave 1 will go to 65%. Now we can add our second property, wave 2, which is the same, although it has a different initial value. And now when we hover our element, both of our waves transition. But the real neat part is that we can also animate these properties. Let's create an animation waves that runs for 5 seconds infinitely. In our keyframes, we're going to set at 50% that wave is 65% and wave 2 is 75%. We can get rid of our wave hover declaration and our transition. Reload the page, and now we have an animated linear gradient using CSS Houdini's app property to give the browser the contextual information it needs in order to animate and transition custom properties. So in review, we can use CSS app property to define custom properties in our CSS whilst providing more contextual information to the browser. Providing a type via the syntax property allows the browser to type check our custom properties, and this also provides us a way to transition and animate between the values of a custom property. Here we have a CSS tree, and to see the bounds of its container, we're going to give it a background color of HSLA 220, 50%, 50%, 0.5. And now we can see the bounds of our tree. To make that tree element resizable, we can use the resize property with a value of both. But resizable elements only work when the overflow is anything but visible. So let's set overflow to hidden. And now we have a resize handle. And we can drag that around to resize our container. We can also constrain how our resize works. If we only want to resize an element horizontally, we can set resize horizontal. And we can see how the cursor changes to indicate that we have horizontal resizing, but not vertical. To resize vertically, we can set resize to vertical. And now our cursor indicates vertical resizing, and we can resize vertically, but not horizontally. And that's it. That's how we create resizable elements with CSS resize. So in review, we can use the CSS resize property to resize an element either vertically, horizontally, or in both directions. But this will only work if the overflow is anything but visible on our element. Let's start by adding an image to our page. We're going to use cat.jpg. And then let's add some styles. We're going to set the width to 50 vmin. By default, our image is using the aspect ratio dictated by its intrinsic sizing. I know that this image is 1920 by 1080, which means it's a 16 by 9 aspect ratio. But what if we want to define a different aspect ratio for our image? Well, we can with the aspect ratio property. To define a ratio, provide a width, followed by a slash, and then a height. We can see that the aspect ratio of our image is now 1 by 1. We can make our image look a little bit better by using object fit cover, and then we can experiment with different aspect ratio. For example, 4 by 1 or 4 by 3, or we can just return it to 16 by 9. We don't need to define a width or height for aspect ratio to work, but it will work with either a width or height. However, if we provide both a width and height, then the aspect ratio will be ignored. And that's it. That's how to use CSS aspect ratio. So in review, we can use the aspect ratio property to define an aspect ratio for elements. We don't need to provide a width or a height, but if we do, we should only provide one or the other for the aspect ratio to be respected.